All right, so today we're going to be looking at how can we actually take those sequences that we looked at yesterday and how can we display them in a graph. So how can we graph those so that they're a little bit easier to look at. So looking at this, it says given the following sequences, identify the sequence and what type of function it is. Okay, so what does the function type look like? And then graph them. Okay, so looking at this, I actually want us to graph them first and then kind of talk about the pieces. So we're going to graph them first. Okay, so looking at this, we first need to decide what type of sequence it is so that we can set up our graph correctly. So looking at this, the first term is 15. So to go from 15 to 12, I'm subtracting 3. From 12 to 9, I'm subtracting 3. And 9 to 6, I'm subtracting 3. Okay, I'm subtracting 3 each time. So remember, adding and subtracting patterns, those are going to be our arithmetic sequences. And guys, a little hint, notice the table had an A sub n. Anytime you see an A sub n, you know that that means it's going to be arithmetic. So now we're going to set up our graph. Now, this first column right here is always going to go on the x-axis. So we're going to label that our n. And that just says, what number is this in the sequence? Is this the fourth number? Is it the fifth number? What's the number? Okay. And then our second column is always going to be on the y-axis, and that's our A sub n. Now the terms are always easy. It's going to be 1, 2, 3, and 4. I always skip 2 so that we can put more on there. We never start with a 0 because there's not a 0th term to the sequence, so we just start with these. If we look at this, my pattern that I noticed was -3, okay? So it's going to be easiest if on our scale we go up by 3s. So we're going to have 3, 6, 9, 10. Nope, not 10. Wow. 12. That's a struggle by Mrs. Mariani. 15, 18, 21. Let's see here. Our sequence only goes to 15, so I'm going to go ahead and stop there. So from here, okay, we have our graph all set up. Okay, so now I'm just going to plot all of my points. So I had 1, 15, so 1 up to 15. Our second term was 2, 12. So these are like our coordinate points. So 2 up to 12. 3, 9. So 3 up to 9. And 4, 6. So over to 4 and up to 6. We do not connect the points because sequences just refer to specific terms, okay? So specific numbers, so we don't actually connect them. So the very last thing we're looking at is what type of function is this? If I were to connect them, we're not going to, but if I did, it would give me a nice straight line. Anytime we have a nice straight line, okay, we know that that's going to be linear. Okay, so anytime our sequence is arithmetic, it's also going to be linear. Those two always go together. Okay, always together. All right. Looking at the next one. So if we scroll down to the next one, we've got our next table is our first term is 1, second term is 3, third term is 9, and our fourth term is 27. Okay, so looking at this, we're first going to find the pattern because that's going to be easier for us to set up our graph. So to go from 1 to 3, I'm multiplying by 3. 3 to 9, I'm multiplying by 3. And 9 to 27, I'm multiplying by 3. If I look at this, okay, since I am multiplying, anytime we have a multiplying pattern, that's called geometric. Okay, and giving you a little hint, anytime you see the G there, that means it's geometric. Okay, the G and the geometric go together. So now we're going to go ahead and set up our graph. Our first column is our n. That always goes on the x-axis. So it's just going to be 1, 2, 3, 4, and we better label. And then our second column always goes on the y-axis. So that's going to be G sub n. Not Q, G. Now my pattern was 3, so I'm going to go up by 3s. So 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. All right. So I have everything set up. Now I just need to plot my points. So my first one was 1, 1. So over to 1. And 1 we're going to estimate is about right there. Then I have 2, 3. That one was easy. Then I had 3, 9. So 3 up to 9. And then 4, 27. So 4 and then way up to 27. Now remember, we do not connect them because sequences are just individual numbers. So looking at this one, okay, now I need to figure out what type of function does this look like if I connect all the points. We're not going to, but if I did, it would look like this. Remember, anytime we have that nice curve like this that gets really close to 0 but never quite gets there, okay, remember that's going to be called exponential. Okay, and these, just like with arithmetic and linear, these always go together. All right, so get that graph down, and we're going to go on to the next one. Remember, if you feel like I'm going a little quick through these graphs, you can always hit pause. Okay, that's totally fine. All right, so going on to number 3. So looking at the next one, I want everybody to go ahead and try this one on your own. Well, scratch that. We're going to go ahead and get this one set up together, and then I'll let you finish it. Okay, so we're going to find our pattern. So to go from 16 to 8, it looks like I'm dividing. It looks like I'm going to divide by 2. But actually, I'm multiplying by 1/2. All right, I need to fix that 2 there, don't I? So that's going to be a 2. And to go from 8 to 4, we're going to multiply by 1/2. And from 4 to 2, we're multiplying by 1/2. Okay, because think about it. Half of 16 is going to give me the 8. Half of 8 is going to give me the 4. Half of 4 is going to give me the 2. So looking at these, okay, anytime we're multiplying by the same number, that's going to be geometric. And we said that anytime it's geometric, we know that that's going to be exponential. Those go together. So looking at this, we're going to go ahead and get our graph set up. Okay, so our x-axis is going to be the n. So we have 1, 2, 3, 4. And my y-axis is going to be, if we look at that, g sub n. And remember, that g up there better match geometric. Anytime we have a g sub n, it's going to be a geometric. So before you even found the pattern, you already know it's going to be geometric. So my pattern is 1/2, but it's difficult to go up by 1/2, so we're going to go up by 2s. $18 and $20. All right, so now we just need to plot all of our points. Maybe if I can zoom in a little bit. There we go. So our first one is at 116. So 1 up to 16. I have 2 8, so 2 up to 8. 3 4, so 3 up to 4. And 4 2, and so 4 up to 2. Now, we're not going to connect the points, but if we did, we would notice that it does give us that exponential curve that we've been talking about. Alrighty, so looking at example 4, this one I want you to go ahead and try on your own. Okay, so go ahead and try number 4, and then you can check your work with mine when you're finished. Alright, so if you try that problem, your answer should look a little bit like mine. We first notice that we're adding 10. Since we are adding 10, this is going to be arithmetic, which matches our table. Remember, arithmetic and linear go together, and if I connect my points, it's a nice straight line, which reminds us of a linear function. On my graph, I went up by tens and I spaced them out a little bit. If you didn't space them out, that is totally fine. Your answer is 100% correct. I just like to do that to give myself a little bit more room. Other than that, though, everything should look good. If you have any questions, circle those for me, and then I can help you when I'm available. All right, so looking at the last one, example number 5, we're determining whether which of the following is linear, quadratic, exponential, or if it's nothing, okay? So, looking at these, anytime something is linear, okay, we know that because the largest exponent is 1, okay? You shouldn't see any exponents except for a 1, okay? But remember, most of the time we don't write in ones for exponents, so really you shouldn't see any exponents at all. If it's exponential, then your x, putting that in quotes, okay, your x is the exponent. Okay, if your x is an exponent, it's exponential. And then quadratic, we know something's quadratic if the largest exponent is 2. So we're going to use those 3 rules, and that's stuff we talked about last semester. So we're going to use these 3 rules to answer the following questions. So the first one, okay, and we have to remember that you always have to simplify if you can. Okay, so you should always be simplifying if possible. So looking at the first one, we have 7x times x minus 3. We need to distribute this, okay, and simplify it a little bit. So when I do that, I'll get y is equal to 7x times x gives me 7x squared. And then 7x times negative 3 gives me negative 21x. Remember, that's kind of like our box method where we multiply everything. Okay, that's all we're doing there. If I look at this, okay, when I multiply those pieces together, my largest exponent is now a 2. Okay, remember the exponents are the little numbers. So my largest exponent is now a 2. Since my largest exponent is a 2, this is quadratic. Looking at the next one, I have y equals 7x minus 5. It's simplified, and I know that that x right there has an exponent of a 1, because anytime you can't see the exponent, you know it's an exponent of a 1. Okay, so we're going to call this linear. All right. Looking at the second or the third one, this one has x and y being multiplied. Okay, so anytime the x and the y are being multiplied, okay, that's actually not going to give us anything, okay? We cannot multiply the x's and the y's together, okay, to give us a function, okay? So this is not linear, exponential, or quadratic, so we just are going to say none. We could call it a relation, okay, but we actually don't even know if it's that, so we're just going to say none. Same for the next one. We never want to divide by x. Okay, it's okay if we are multiplying, and it's okay if our x is an exponent, but anytime we divide by x, okay, that's also not going to give us anything. You could put this into the calculator and check it, okay, and it's actually not going to give us exponential, linear, or quadratic at all. So we're going to say none to this one as well. All right, looking at the next one. Here we see that our x is an exponent. Since our x is an exponent, we're going to call that exponential. Alrighty, we're going to go ahead and stop there for now. Okay, if you have any questions, please let me know. If not, move on to your homework.